Welcome back, everybody. Today's lesson is going to be a review of the triangle angle sum theorem that we talked about before break. And the triangle angle sum theorem and the ideas behind it are actually pretty brief, so this should be a shorter video. And it simply says this, and it's what you can see in the picture. The sum of the interior angle measures of any triangle will always be 180 degrees. And that's what you see here in the pictures as well. A little bit of new notation for us. You see this M before the angle symbol and then A. And what they're literally saying is M stands for measure. So the measure of angle A plus the measure of angle B plus the measure of angle C, it's got to equal 180. If it's not 180 degrees, it is not a triangle, and it is pretty much that straightforward. So we're going to look at a couple different ways we can apply the angle sum theorem for a triangle, and then let you guys get to your practice as well. Let's take a look at some different ideas. One of the first things that we can do with this theorem is decide, based on angle measures, is the shape we have actually a triangle or not? And that might sound a little funny, but the idea behind this is that we're not going to actually have the picture. So we would see something like this, where you'll be given three different angle measures, and you're going to be asked to use the theorem to say, well, would this actually make a triangle? So here we see that we have a 30-degree angle, we've got a 60-degree angle, and we've got a 90-degree angle listed for us. But what we're going to do is we're actually going to find the sum of those to see what we get. In other words, we're going to take our 30 degrees plus our 60 degrees plus our 90 degrees and say, well, where does that get us? And using a calculator to double check this would be a really good idea, because you would find out that first 30 plus 60 is 90, and then 90 plus the other 90, where does that get us? And 90 plus 90 really is 180, and that's exactly where we would hope to get if it's supposed to be a triangle. So for this first one, after you finished all this, you could say, yes, this is a triangle. Okay, so if you had a figure with a 30 degree, a 60 degree, and a 90 degree angle, yep, we've definitely got a triangle. Let's look at another example. So if we had a second figure that had a 100-degree angle, a 35-degree angle, and a 55-degree angle, again, is this actually a triangle? So we'll use the angle sum theorem to find the sum and add up all three of our angles. And it's really important that you take the time to actually check these sums either by hand or in a calculator, because some of your first impressions, at least, might be a little misleading here. So we go to add things up. We'll take 100 plus 35, which is 135, plus 55 more. And when we take 135 plus 55, we actually end up with 190 degrees. And of course, we know, well, that doesn't equal 180, and 180 has to be the number. That's our special number with triangles, of course. So in this case, we could simply go back and say, no, we do not have a triangle if the angles are 100 degrees, 35, and 55 degrees. So that's one of the first things we can do with this theorem. After that, we can also approach a whole different set of problems where we're going to try and find some missing information, specifically a missing angle measure. So in this image here, we see that we have, of course, the triangle AMT, or whatever order you're going to read those letters in. And we have two of the angles listed. We do have a 27-degree angle and an 82-degree angle. And they want us to, of course, find that missing angle. So we're still going to apply that angle sum theorem, but just by starting off with the idea that the sum, meaning if we add all of these angles together, that it's going to have to equal 180 because it is a triangle. So we start by writing out an expression like this: 27 degrees plus 82 degrees plus, and here's the part that feels a little awkward to some of us, is that we're going to add x, even though we don't know what it is, because we know if we could do that, it would have to equal 180 degrees. Again, that's got to be clear because, well, you're looking at a triangle. It already is. After that, we can simplify this, and what we're going to end up with is hopefully a one or two step equation that we can use to find the missing angle, or sometimes, like we saw in the last video, they might just ask you for the value of x itself. All right, first thing we can do is simplify these constants. So 27 plus 82 should be 109. And everything else remains the same. Just for the sake of helping things make a little bit more sense visually, since this is addition, I'm going to flip the order real quick, just make it x plus 109. You don't have to do that step, but I think it makes more sense for me, because then follow along with my algebraic steps. I know I can just simply undo or do the inverse operation of what was happening to the variable, and that was addition. So we're going to go ahead and use subtraction. We're going to subtract 109 from both sides and see what happens. On the left-hand side here, where we have 109 minus 109, that's 0, and we are just left with x. That's good news. And then on the right, we need to subtract 180 minus 109, and we should be left with just 71. So x happens to be 71, and in this case, that's also the size of the angle, so that would end up being 71 degrees. So that's the second type of problem you guys are going to see, is it being asked to find missing information like x or the angle size itself. But then they could combine ideas from this lesson and from the last one as well, where we classified triangles. So be prepared for that. What I mean is, for this triangle, let's see, we just found out that x equals 71 degrees. Well, I know that's an acute angle, and 82 is acute, and 27 is acute. So I might even get to label this one an acute triangle, but I know I need to give it two names. So I'm looking at the side lengths. I don't have a lot of proof. Because all three angles are different, I'm pretty confident it's also going to be a scalene triangle. So you might have to classify them as well, but certainly not in all of the examples. But that's pretty much it for the angle sum theorem. Remember, that's the theorem that says that the sum of the interior angle measures is always going to be 180 degrees. That's the information that you've got to dedicate to memory moving forward. So good luck with the assignment. If you guys need help, I will be available for tutorials. That information is up on Google Classroom for you, and I'll see you next time.